Okay, start recording. So, today we will talk about Pure 3 9709 paper 3. Okay, we'll talk about start from chapter 1. Okay, for your information, you have 9 topics. Okay, we have algebra, exponential and log, trigonometry, differentiation, integration, numerical methods, differential equation, vector, and complex number. So, first of all, these 3 topics, so first 3 topics, okay, first 3 topics, okay, this is what we consider as a basic. Okay, so we call this as a basic because it is needed for all the topics in your P3. Okay, students will definitely need to know how to do the algebra for the chapter 1 to 3 in order for you to actually able to answer the rest of the topic. Therefore, we call it basic. If students actually okay with the basic, we'll actually guarantee them a pass for the paper. Okay, then the next section students need to looking at is the differentiation, integration, and new differential equation. Okay, this will be the second part, and this will be involved with differentiation integration, which is calculus. Okay, so as you can see here, in your P3, there are a lot of portions of the calculus that you need to know how to do. Okay, in differentiation, integration, and all the other things, and inclusive of application. If the students okay with the basic and the calculation, we actually students should be able to get a minimum of B already. Then the rest of the topic will be the numerical methods, vector, and complex number. Okay, these will be independent topic. Okay, although they are independent topic, they are still need you to maybe understand chapter 1 to chapter 7. Okay, which is the basic and the calculus part that you may need to know about their rules in order for you to do the calculation and so on. Okay, out of all, complex number is the hardest topic. Okay, so therefore from here you can see that students will be using the chapter 6 and 6, 8 and 9, okay, especially 8 and 9 to determine whether they are the A or A star students. The format of the paper is 1 hour 50 minutes. Okay, it will be total of 75 marks, representing the 30% of your A-level grade. Okay, without further ado, let's continue. Topic 1. Okay, well, topic 1 is will take some time. Okay, because it's actually the basic. We just want to make sure that students are actually okay with the basic. So I split into A to I. Okay, we have a long division, synthetic division, remainder theorem, factor theorem, partial fraction, binomial expansion, modulus inequality, modulus equation, inequality, and graph and transformation. Of course, this graph and transformation here is not really fall under the algebra part, but the graph and transformation will be very helpful when you actually dealing with the questions. Okay. Number 1, long division. So okay, so let's say how do we actually do this. Okay, this part I put a long division and synthetic division together. Most of you from IGCSE, you already know how to actually do this work. Okay, for the rest I just want to show you again how to actually do this thing. So x cubed plus 2x squared minus 17x plus 6 divided by x minus 3. Okay, so x squared times by x give you x cubed, x squared times by negative 3x squared. Draw a line. Okay, then okay, so the operation is a minus, so x cubed minus x cubed is gone, 2 minus minus 3, so you have a 5x squared minus 17x plus 6, so plus 5x, so 5x times x give you 5x squared, 5x times negative 3, negative 15x. Okay, so as you can see, you choose the 5x with the x in order to get rid of the first term here. Okay, then the operation is the minus. Okay, so minus 17 plus 15, so you have minus 2x plus 6, then followed by minus 2. Okay, minus 2, as you can see, minus 2 times by x, get rid of this negative 2x, so negative 2x, then plus 6 here with the minus, then it divided perfectly, so you have your quotient, okay, of x squared plus 5x minus 2. So you can see that this x cubed plus 2x squared minus 17x plus 6, okay, divided by x minus 3 gives you, okay, x squared plus 5x minus 2. Okay, so what about synthetic division? Synthetic division from this x cubed plus 2x squared minus 17x plus 6. Okay, we're trying to write out the number. So we have a 1, 2, negative 17, negative 17 and the 6. Okay, if you're not sure, you can actually write the coefficient up there. Okay, the term. So you have a x cubed, x squared, x and the c. Then operation is a 3. So where do we actually get this 3 from? We let x minus 3 equals to 0. The operation is a plus. Okay, the first number you do not disturb, so you just bring it down. So you have a 1. So 1 times 3 become 3. Okay, 1 times 3 become 3. So the operation is a plus. You add them together, 5. 5 times 3, 15. You put it here. So you add them together, negative 2. 3 times negative 2, you have a negative 6. Then you have a 0 up here. So after the 0, I draw a line. What does this 0 mean? What does this 1, 5, and negative 2 actually means? 0 means you have no remainder. Okay, and this 5, 1, 5, negative 2 actually means cx and x squared. We read it backwards. Therefore, you will have a x squared plus 5x minus 2 as a result. That will be your synthetic division. Okay, although that synthetic division here is actually look very nice, okay, but uh, uh, during exam you need to know about the pro and cons for this. Okay, so synthetic division only work for linear divisor of with coefficient x equals to 1. Okay, with coefficient x equals to 1. So what does it mean by linear divisor? Ax plus c is a linear divisor. Mx plus c is a linear divisor. X squared is not a linear divisor. Okay, and furthermore, you need to be a coefficient x equals to 1. Okay, if it's not equals to 1, then it doesn't work. That means other than this, okay, you have to go back to the long division. So long division, the chances of making mistakes, okay, is there, but you need to make sure that you actually do the work carefully in order to avoid the mistakes. Okay, so this is long division and synthetic division. Okay, so during exam, okay, it's important for us to make sure our algebra is correct, because as you can see, back to the front, I say that, okay, this is the basic topic, okay, and it needed for the rest of the topic, isn't it? Therefore, it's always important for you to check whether your answer is correct or not. So how do you do checking? So how do you do checking? So you can actually sub a random number. Okay, let's say x equals to maybe 1. Okay, so inside the expression, so I have 1 cube plus 2, oh, okay, 1 plus 2 minus 17 plus 6 over 1 minus 3. So I will have, let's see, let me press calculator. So 1 minus 2, oh sorry, 1 plus 2 minus 17 plus 6 over 1 minus 3. So I have a value 4. Okay, on the right hand side, I have a x squared plus 5x minus 2. So I have a 1 plus 5 minus 2. So 6, 4. So you can see they are the same. So therefore you know that you actually do it correctly. Okay, so this is how we do checking. So there will be exercises here that you actually can do for the long division. As you can see, I didn't put any answer here. This is for you to do your own checking. Okay, so yeah, you're actually confident whether you do the things correctly or not. Next, we want to go for remainder theorem. Okay, so remainder theorem is, okay, so put it this way. Okay, let me rephrase the thing. Okay, remainder theorem is given px, okay, divided by ax minus b, okay, which is a linear divisor. So as you can see, quadratic divisor, it doesn't work here. Divided by ax plus b minus b. Then its remainder is p of b over a. Okay, so this thing is the remainder theorem. So we're trying to verify with the rule. Okay, let's see. So I have as you can see from this example, I have a x cubed minus 20x plus 3, okay, divided by x minus 4. So I can do it long division, I can do it synthetic division, I can do it by remainder theorem. So I have a x cubed plus 0x squared minus 20x plus 3. As you can see, I don't have an x squared term, so I put in the 0 there. So divided by x minus 4. Okay, so something times by x, you get rid of the x cubed, so x squared, x cubed, then minus 4x squared. Okay, and the operation is a minus. 0 minus minus 4, so 4x squared minus 20x plus 3. Then something times by x give you 4x squared plus 4x. So 4x squared minus 16x minus, okay, minus 20 minus minus 16, so minus 4x plus 3. So okay, something times by 4 times by x give you minus 4x, so minus 4. So minus 4x plus 16. Okay, the operation is minus. So 3 minus 16, so you have a minus 13 here. Okay, so the remainder from doing long division, okay, this working tells us that the remainder is negative 13. Okay, it's negative 13 here. So let's try to see it by using synthetic division. So I have a x cubed, x squared, x and the c with a 1, 0, negative 20, and 3. So the operation is a 4 plus. Okay, so I do my calculation. 1, I do not disturb, I bring it down. 1 times 4, so I write here 4. So add them together 4. 4 times 4, 16. So I have a negative 4, for negative 16. So I have a negative 13. So you can see this one also give me the remainder of negative 13. Okay, so if I use remainder theorem, so I will let px equals to x cubed minus 20x plus 3. Then I will sub x equals to 4. Where is this 4 come from? It's from the x minus 4 equals to 0. So I have a p of 4 equals to 4 cubed minus 20 times by 4 plus 3. So 4 power 3 is 64 minus 80 plus 3. So 64 minus 80 plus 3. So you have a negative 13. So you can see all the answers here, they are consistent. It's just a different way for us to do it. Okay. So sometimes the question may ask you to use a specific way. If the question asks you to use a specific way, you are required to show the working, the correct working. Okay. Then, okay. So sometimes you have a reverse questions. Okay, reverse questions. So for the reverse questions, okay, it's already tell you the remainder equals to 3. We are required to find what is the value of a that provide that. So I let px equals to 8x4 minus 4x cubed plus ax squared minus 1. Okay, then I substitute x equals to negative 1 over 2. So sub, okay, x equals to negative 1 over 2. According to the information by remainder theorem, they tell us that p of negative 1 over 2 equals to 3. This is the information that they tell us. Okay, this is the information that they tell us. So all I need to do is just do my calculation. 8 and negative 1 over 2 power 4 minus 4 negative 1 over 2 power 3 plus a negative 1 over 2 square minus 1 equals to 3. Okay, then I simplify the value, so I have a 1 over 2 here, so minus plus 1 over 2 here, then this is a over 4 and minus 1 equals to 3, so a equals 2. So you press your calculator, so 3 plus 1 minus 1 times by 4, so equals to 12. Okay, so although that you get this as your answer, okay, but as I say, most of the time we actually need to make sure we are wonder whether our answer is correct or not. We want to make sure. So how to do checking? How to check? Okay, it's always the questions here. So what we need to do is, okay, we rewrite the equation first. Okay, so 8x4 minus 4 4x cubed plus 12x squared minus 1. So we need to substitute x equals to negative 1 over 2. Okay, so p of negative 1 over 2 here. Okay, so you just need to press your calculator. Negative 1 over 2, 4 minus 4, negative 1 over 2 cube plus 12, negative 1 over 2 minus 1. Okay, it is the square here first. So I check with my calculator. For those who are good with calculator, of course you actually can use the calculate button. Okay, you can use the calculate button. So 8x4 minus 4x cubed, okay, plus 12x squared, okay, minus 1. So press the calculate button with negative 0.5. So it gives me 3. Okay, then you know that your answer of a equals to 12 is correct. No problem with that. Okay, then so from here, you have the remainder theorem questions that you can do. You can, as you can see from this exercise here, you have the forward type of question. Okay, you have a reverse type of questions. Okay, you may be sometimes involved with simultaneous equation that you need to know how to do. The answer is over here. Then you can check your answer with this. Next, we have factor theorem. Okay, factor theorem. Factor theorem is actually a continuation of remainder theorem. Okay, so what does the factor theorem actually says? Okay, so given px, if p of b over a equals to 0, you have this as a if, the condition. Then, okay, we have two possible outcome. We say ax minus b is a factor of px, or we say x equals to b over a is a root of px equals to 0. Please understand that this one is referring to expression, this one is referring to equation. Therefore, we're using the different words for different situation. Okay, we're using different words for different situation. So this is factor theorem. Okay, so show that x minus 2 is a factor of this, okay, by long division by factor theorem. Okay, so over here, of course, by using long division, okay, we can actually can do it. Okay, for the sake of simplicity, I use synthetic division. Okay, therefore I have x cubed, x squared, x and c. So 1 minus 4 and minus 4 here. Okay, then I substitute 2 with a plus. Okay, so 1 I do not disturb. 1 times 2, 2. Then this one is a 3. 2 times 3, 6. Then you have 2. 2 times 2, 4. So you have a 0. Okay, so you can see that they give you the remainder theorem 0. So Therefore, x minus 2, it is a factor of it. So how do we actually do a factor theorem? So first we let px equals to x cubed plus x squared minus 4x minus 4. Okay, then we sub x equals to 2. So p of 2 equals to 2 cubed plus 2 squared minus 4 times 2 minus 4. Open it up. 8 plus 4 minus 8 minus 4 is equals to 0. After this line, you're supposed to write your conclusion. So hence, so x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. Okay, so this is how you do the writing. Okay, then okay, this one I need. Okay, there will be exercise 1D here for the factor theorem that you can do. Okay, so over here you have your for answer that you can actually do your checking. Okay, stop recording. Okay, start recording. Okay, we will continue with the next section, with section E, partial fraction. Okay, so of course, for some of you have no idea what partial fraction is about, let's look at some introduction first. Okay, so for example, okay, we look at the number. I want to sum the number 1 over 3 plus 3 over 8. So as you can see, this is the number. Usually what we do during primary school, we make them the same denominator. So the 1 over 3 times by 8 above times by 8 below, so by 8 over 24. For the 8 over 3 over 8, I times by 3, I times by 3, therefore I have a 9 over 24. Now you have the same denominator, then we add them together, we have a 8 plus 9, so you have a 17 over 24. Okay, this is when we deal with the number. So what if we have unknowns alphabet? So I have a 2 over x plus 3 minus by 1 over x plus 1. Okay, so same thing, I make them the same denominator. As you can see, the first fraction I multiply by x plus 1 over x plus 1. Then the second expression I multiply by x plus 3 and over x plus 3. And I open up the bracket for the top part. So I have a 2x plus 2 minus x minus 3. So this part, make sure that you do not do any algebra mistakes. A lot of students actually make algebra mistakes over here. Then you simplify the expression. So 2x minus x, you have an x. 2 minus 3, you have a minus 1. So then the x minus 1 over x plus 3, x plus 1, this is your simplified fraction. Okay, combine them, become a single fraction. So what exactly is a partial fraction? Partial fraction is a process to reverse the process of question B. That means this is the question, this is the answer, because we want to reverse the process. Okay, so the thing will be, how do we actually do the questions? Okay, so for this partial fraction part, we actually got two types. Okay, so given clue, without clue. Okay, so put it this way, with clue, without clue. Okay, with clue or without clue. So the method I'm going to show you is the one without clue. Okay, because we cannot assume all the time that the question gives you the clue. So you have to practice the partial fraction part without clue. Okay, this part is significantly important throughout your P3 because this is the as I say, this is chapter 1 algebra is needed for other topics, and this partial fraction actually appear in several parts throughout your P3. Okay, so therefore, if your partial fraction, let's say part A is your partial fraction question, okay, then part B is other thing. Okay, if your partial fraction is wrong, then the other part of course will be affected. Okay, so therefore you have to make sure your partial fraction is perfect in order for you to actually continue with the other parts of the questions. Okay, if you always have problem with the partial fraction part, of course, it will jeopardize the rest of it. So how do we actually do the step? Okay, number one, we try to go through the rule first. Okay, check the power of numerator and the denominator. If the numerator greater equals to denominator, we go for step 2. If the numerator lesser than denominator, we go to step 3. Number 2, step 2, you do long division. Only use the remainder and denominator to continue in step 3. Step 3, factorize denominator completely. Okay, step 4, right assumptions. So, okay, this one right assumption, you have to make sure you refer to your step 3. What are the results that you get for your step 3? Okay, then, over here, so step 4, okay, I split into 4 parts. Okay, a non-repeating linear factor. So you have at the bottom here, you have x minus a, x minus b, x minus c. They are all non-repeating. That means they only appear one time. Power 1, power 1, power 1. Okay, you have a repeating linear factor. So you have x minus a power repeated for n time. Okay, repeated for n time. Okay, you have a non-linear factor. So that means you have maybe a quadratic or cubic that you cannot factorize any further. Okay, that you cannot factorize any further. For the first one, non-repeating linear factor, so you write it as a over x minus a, b over x minus b, c over x minus c. For the repeating linear factor, so you have a over x minus a power 1, b over x minus a power 2, all the way up to your power, you finish all your power. Okay, then if it's a non-linear factor, okay, let's say you have a quadratic at the bottom, then you write your assumption as a linear on top. Okay, so and after that, this ABC, they have a value ABC, right? So you need to solve this ABC by using expand and compare, by substitution or shortcut. Okay, please take a moment to pause over here so that you actually understand the step first. Okay, make sure you understand the step, then we continue with the example. Okay, step 1, 2, 3. Okay, step 4. Then step 5 here. Okay, so now let's look at example. Okay, let's say this is the question that we're looking at. Okay, this is the question that we're looking at. Maybe put down. Okay, write it all the way down. Okay, partial fraction. Okay, this is the question. So step 1 says we check the power of the numerator and denominator. The top is a power 1. Okay, the bottom is power 2. Okay, so we don't need to do step 2. Okay, we are no need to actually do step 2. So, okay, step 3, factorize the denominator completely. It's already been factorized it nicely. Okay, so x plus 3, x plus 1. So step 4, well, we have to write assumptions according to what we got from step 3. So this one, you can see that this is a non-repeating linear factor. Therefore, I will write my assumptions as a over x plus 3 plus b over x plus 1. Okay, I will write my assumption in this way. Then step 5. Step 5 here, I mentioned about 3 methods. Expand and compare by substitution and shortcuts. Okay, I'm going to show you all 3 methods. Okay, expand and compare. Method 1. X and compare. Okay, so first I multiply both sides by denominator. So I will have x minus 1 with a of x plus 1 plus b of x plus 3. Okay, so I have x minus 1. So ax plus a plus bx plus 3b. Okay, then after that, okay, I simplify them, combine the like term together. I have a plus bx plus a plus 3b. The method is called expand and compare. So after I expanded, I also, of course, I need to do comparison. So I have a plus b equals to 1. Okay, I will have a plus 3b equals to minus 1. So you can see I compare this with this. I compare this with this. Okay, after that, we're trying to solve the a and the b. Okay, this will be the easy part because you can actually press your calculator. Okay, so 2, so 1, 1, 1, 1, 3 minus 1. So you will get your value a equals to 2, a equals to 2, and b equals to minus 1. Okay, then you will see that your x minus 1 over x plus 3, okay, x plus 1 equals to 2 over x plus 3 minus 1 over x plus 1 as a result. Okay, because this is an example that we got from an example above, okay, from the introduction part above, we know that this answer is true. Okay, so let's look at method 2. Okay. Okay, let's look at method 2. Method 2 is called, okay, method 2 is called by substitution. Okay, by substitution. Okay, same thing, I'm going to multiply both sides by denominator. Okay, so I will x minus 1, triple line, a x plus 1 plus b x plus 3. Okay, then after that, I'm going to sub. Okay, x equals to minus 1. Okay, where is this x equals to minus 1 came from? X equals to minus 1 is from the x plus 1 equals to 0. I'm going to sub x equals to minus 1. So I have a minus 1, okay, goes to a of minus 1 plus 1 plus b of minus 1 plus 3. So of course you will have your value of b. Your b will equals to minus 1 here. Okay, then you sub, okay, x equals to minus 3. Okay, the first factor you already use the information x plus 1 give you minus 1. Of course the second one will give you from the x plus 3 give you minus 3. So I will have minus 3 minus 1 equals to a of minus 3 plus 1 plus b of minus 3 plus 3. Okay, so of course, if you simplify the value, you have a equals to 2. You will see that it's a consistent answer. Okay, next, this is your method 2. Next is method 3. Okay, method 3, shortcut. But please understand this shortcut only works for non-repeating linear factor. As you can see from this question, x plus 3 only appear one time, x plus 1 only appear one time. Therefore, this is the shortcut question that the shortcut method we can use for this question. Then, Okay, how do we actually do for this question? So x minus 1 over x plus 3, x plus 1. Okay, so equal. So I write two denominator here at the bottom first. Okay, so what do I actually write above? Okay, so for the first fraction, I write x plus 3. So over here on the left side, I use my finger to cover x plus 3. So you will see only x minus 1 and x plus 1. You will see only x minus 1 and x plus 1 because my finger already cover x plus 3. So you will write, okay, minus 1 blank minus 1 over blank plus 1 above. Okay. Of course, you're not going to write bracket like this. I just is the writing the bracket is just to show you as a lesson. Okay, blank minus 1 over blank plus 1. So because of the, you see x minus 1 and x plus 1. The second fraction, you have x plus 1. So you use your finger to cover x plus 1. When you cover x plus 1, you only see x minus 1 and x plus 3. Okay, you only see x minus 1 over x plus 3. Similarly, you're going to write, okay, blank minus 1 over blank plus 3 on top. Okay, so after that, what exactly is the value that actually substitute inside the blank? For the first fraction, you see x plus 3, you are referring to x plus 3 denominator, isn't it? So you substitute minus 3 here. For the second fraction, you're referring to x plus 1 denominator, so you substitute minus 1 here. Okay, the concept is similar to the substitution. Okay, let's simplify the number. So I have a minus 4 over minus 2 over x plus 3 plus I have a minus 2 over 2 over x plus 1. Okay, so you can see it's 2 over x plus 3 minus 1 over x plus 1. Done. That's why this is a shortcut. Okay, this is actually how do I do the calculation. Okay, so over here you will have questions that you can actually practice. Okay, for the partial fraction here. Okay, you can see that these questions here, they are no without clue question. Without clue question. That means you are required to figure out the assumption yourself. This one is the clue given. Clue given with clue. Okay, with the clue questions, okay, then you can immediately go for step 5 straight away. You can go for step 5 straight away. You don't need to go through step 1, 2, 3, 4. You can, with clue given, you can actually go through step 5 straight away. Okay, then this will be the answer here that you can do your checking. Stop recording. Start recording. Okay, the next sections that we're going to do for chapter 1 is binomial expansion. Okay, then okay, so this binomial expansion will be slightly different from your P1 binomial expansion. Okay, this according to your P1 binomial expansion. So from P1, okay, we are dealing with a plus b power n equals to summation of r equals to 0 and cr a power by n minus r b power of r. Okay, so where n is a positive integer. Okay, so now for P3, we are talking about n as a negative integer or a fraction number. Okay, so the formula that we're looking at will be this one. Okay, the formula that we're actually referring. Okay, okay. So where n is a positive integer, so the formula that we are referring is referring to this one. Okay, let's see. Okay, then so if let's say for the first example, okay, so I have a 1 plus x power 4, okay, so we actually can use our P1 formula, okay, so I will have so 4 choose 0, okay, 1 power 4, x power of 0 plus 4 choose 1, okay, 1 power 3, x power 1 plus 4 choose 2, okay, 1 power of 2, x power of 2 plus 4 choose 3, 1 power of 3, x power of, sorry, x 1 power of 1, x power of 3 plus 4 choose 4, 1 power of 0, x power of 4. Okay, so I will have the information as let's say 1 plus 4x plus 6x squared plus 4x cubed, okay, plus x4 as a result. Okay, so this is when we use a P1 method. Okay, P1. So now let's look at what about we have a P3 type of questions. Okay, we have a P3 type of questions. So if I have a 1 plus x power of minus 1, as you can see, this power here is a negative integer. Okay, so we will use the formula like in this way. Okay, so I follow the form. So 1 plus negative 1, okay, of x plus negative 1, negative 2 over 2 factorial. So negative 1, the n, negative 2 is n minus 1. Okay, so together with then with x squared. Okay, then they want first 4 terms. So the first term, the second term, the third term. So we continue minus 1, minus 2, minus 3 over 3 factorial. Okay, and x cubed. So 1, 2, 3, 4, the 4 terms. So plus dot 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 at the back. Then we simplify the thing. 1 minus x. So I simplify, I have a positive of x squared. I simplify, I have a negative of x cubed plus dot dot dot. Okay, as a answer. That will be my expansion for 1 over 1 plus x. So what about the second one? You have you can see square root of 1 minus 3x. Okay, so 1 minus 3x power of 1 over 2. As you can see, the fraction, the power is a fraction. Okay, so we will use a P3 formula. Okay, so 1 plus 1 over 2, okay, with negative 3x plus 1 over 2, negative 1 over 2 over 2 factorial of negative 3x squared, okay, plus 1 over 2, negative 1 over 2, negative 3 over 2, okay, over 3 factorial of negative 3x cubed plus dot dot dot. Okay, so of course I simplify the number. So 1 minus 3 over 2x. Okay, so minus 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 3 9 9 over 8. Okay, x squared and minus 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 minus, so it's a negative. Okay, 3 here cancel off. So I have a 27 over 16 x cubed. Okay, so this is when you apply the P3 binomial expansion formula up here. Okay, so this one for P3 expansion, okay, there will be limitation. Okay, there will be the theory part of it. the theory says the expansion only valid, okay, for modulus of the back term lesser than front term. Okay, lesser than front term. So let's say I want to have 1 minus x power of 1 over 3. Okay, so for the sake of illustration, I'm going to expand this, okay, up to x cubed. So 1 plus 1 over 3 negative x power 1 plus 1 over 3 negative 2 over 3, 2 factorial, okay, negative x squared, okay, and 1 over 3 negative 2 over 3 negative 5 over 3 over 3 factorial of negative x cubed plus dot dot dot. Okay, I'm going to simplify the number 1, okay, minus 1 over 3x. Okay, so let me simplify the number using calculator. So minus minus minus, so negative 1 over 9 of x cubed, x squared. Okay, then the next one I can have so I have a minus 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 negative 5 over 81 of x cubed. Okay, so it says, the theory says the expansion only valid for modulus of back term lesser than front term. That means over here, this is only true if modulus of negative x lesser than 1. The negative x is the back term, then the 1 is the front term. So if we simplify it, I have x is in between of minus 1 and 1. So in the end, what it means is this thing here is only true for the value x is in between minus 1 and 1. How is it so? Let's look at example. Okay, so if I choose, okay, x a number, let's say 0.5. Okay, so 1 minus 0.5 power of 1 over 3, I press inside calculator, cube roots of 0.5. So I have a number 0.793700526. Okay, so if I put it into the right hand side, okay, so 1 minus 1 over 3, 0.5, minus 1 over 9, 0.5 square, minus 5 over 81, 0.5 cube. Okay, so let's see, 1 minus x over 3, okay, minus x square over 9 minus 5x cubed over 81, calculate, okay, 0.5. So I have a 0.79783950062. You can see that they are not entirely the same, but the first two decimal place is still accurate. Okay, this is due to I have a plus dot dot dot, a long dot 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 at the back, okay, that I being ignored. So they are not entirely the same, but they are almost the same. So this one is x equals to 0.5. What if I choose a number, okay, outside of the interval? Okay, so let's say now I choose x equals to 1.5. So obviously this 1.5 is outside of the interval of negative 1 and 1. Okay, so from the left hand side, I have a 1 minus 1.5 power of 1 over 3. Let's see. Okay, 1 minus 1.5, okay, power by 1 over 3. So I have a negative, okay, 0.7937000526. Okay, so for the right hand side, let's see what we're going to get. So 1 minus 1 over 3, 1.5, minus 1 over 9, 1.5 square, okay, minus 5 over 81, okay, 1.5 cube. Okay, so let's see what we get here. Minus x over 3 minus x square over 9 minus 5x cubed over 81. Okay, calculate 1.5. So it gives me a positive number of 0.04166667. Okay, this is a 0. You will see that the left hand side is totally not the same as right hand side. They are very different. So you can see that the expansion is not true when x equals to 1.5. Therefore, the theory appears in this way. Okay. Then, okay, after that, you may have substitution questions. Okay, substitution questions. Okay, so from this square root of 1 minus 2x, so I write as a 1 minus 2x power 1 over 2. Okay, I do my expansion. 1 plus 1 over 2, negative 2x power 1, plus 1 over 2, negative 1 over 2. Okay, 2 factorial of negative 2x power 2, plus 1 over 2, negative 1 over 2, negative 3 over 2. Okay, 3 factorial of negative 2x power of 3 plus dot dot dot. Okay, equals to 1 minus x. This one minus 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 minus. Okay, to 1 over 2x squared. Okay, this one is a minus 2, 3. Okay, 2, 2, 2 cancel 1 over 2 of x cubed. Okay. Then I want to find a suitable value for approximation for square root 2. Okay, so I sub, okay, x equals to 0.01 to the left hand side, to the right hand side. So I have a 1 minus 2 times 0.01. Okay, approximate to 1 minus 0.01 minus 1 over 2, 0.01 square, minus 1 over 2, 0.01 cube. Okay, so what do I actually get here? 1 minus 0.02, okay, square root. So I have a 7 over 10 of square root 2 approximate to, okay, so 1 minus x minus 0.5x squared, okay, minus 0.5x cubed, calculate 0.01. So I have a 0.98999495. So over here, you will see that square root 2 is approximate to 10 over 7 of 0.98999495. Okay, so times 10 divided by 0.7. Oh, sorry, divided by 7. So you have a 1.41421357. Okay, compared to the actual number, actual value of square root 2 equals to square root 2. You have a 1.4142135562. You can see they are not entirely the same, but it's still accurate up to a certain value, up to 5. You can see accurate up to 5 here. So 1, 2, 3, 4, 5, 6, 7, 7 decimal place. Okay, so this is one of the type of question of approximation question. Next, what if the front term is not equals to 1? Okay, front term is not equals to 1. Then we have a 4 here. Okay, so front term is not equal to 1. You need to do your algebra manipulation to make it 1. So you have a 4 plus x power 1 over 2. Okay, you need to do your algebra thing. 4, take it out, 1 plus x over 4 with 1 over 2. So as you can see, whatever that you do, you have to create a 1 there. Then you have a 4 power 1 over 2, 1 plus x over 4 power 1 over 2. Okay, you have a 2 times 1 plus x over 4 power 1 over 2. Okay, then you can actually do your expansion. Okay, 2 times of 1 plus 1 over 2 x over 4, okay, plus 1 over 2 negative 1 over 2 of 2 factorial x over 4 square, okay, first 4 terms. So 1 over 2 negative 1 over 2 negative 3 over 2 of 3 factorial, okay, x over 4 cube dot dot dot. And of course, you simplify your thing. Okay, so 1 plus x over 8. Okay, you have a minus here, 2, 2. Okay, what will be the value? So 1 over 128 x squared. Okay, so minus plus 1 over 512 x cubed. Okay, so plus dot dot dot. Remember to open up the bracket. So you have 2 plus x over 4 minus 1 over 64 x squared plus 1 over 256. Okay, x cubed. That will be your answer. Okay. And you may have questions that involve with partial fractions. Okay, you may have questions that involve with partial fraction that you need to know how to do. Okay, so over here. So with partial fraction, of course, you can see that we need to do the partial fraction first. So this is a non-repeating linear factor. Therefore, I go straight for the shortcut. So 4 minus 5x over 1 plus x, 2 minus x, so equals to 1 plus x at the bottom, 2 minus x at the bottom. So I have 4 minus 5 of minus 1 over my 2 minus minus 1. Okay, then 2 minus x. So I have a 4 minus 5 of 2. Then you have a 1 plus 2. Okay, then you have a this one is minus 5, 9. This is a 3, so you have 3 over 1 plus x. Okay, so this is 4 minus 10 minus 6, 3, so minus 2 over 2 minus x. Okay, so I managed to write this as a partial fraction. Now I need to do my expansion. So I continue. Okay, equal. So 3 of 1 plus x power minus 1 minus 2 of 2 minus x power minus 1. You can see that this part here is not 1, so I need to do some sort of algebra manipulation. So 1 plus x power minus 1 minus 2 of a 2 minus 1, 1 minus x over 2 of minus 1. Okay, then now I continue with my expansion. So 3 of, I only need to do up to x cubed. So I have a 1 plus minus 1 x plus minus 1 minus 2 over 2 factorial of x squared plus minus 1 minus 2 minus 3 of 3 factorial of x cubed. Okay, plus dot dot dot. Okay, minus 2 power 1 over 2 cancel off. So I'm left with 1 plus minus 1 negative x over 2 plus minus 1 minus 2 over 2 factorial negative x over 2 square plus minus 1 minus 2 minus 3 over 3 factorial of negative x over 2 cube. Okay, so I simplify it. So 3, 1 minus x, so plus x squared minus x cubed minus, okay, 1, this one is plus x over 2, okay, then you have this one minus 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 positive, so 2 cancel off, x squared over 4, then minus positive, okay, then x cubed over 8, okay, plus dot 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 equal, so I simplify it, so 3 minus 1, 2, minus 3 minus 1 over 2 minus 7 over 2x, 3 minus 1 over 4, 11 over 4x squared, minus 3 minus 1 over 8 minus 25 over 8x cubed is true. Okay, so show. So this will be how you do your working. So find the range of x which is the expansion is valid. So you can see you have two expansions here. One is for the 1 plus x power negative 1, one is for 2 minus x power negative 1. So okay, so for 1 plus x power negative 1, it will be give you modulus x lesser than 1. For 2 minus x power negative 1, it will give you modulus x lesser than 2. Then you draw your number line. So you have a minus 1, 1, and minus 2, 2. Okay, this is the interval. This is the interval. You find the interval that being overlapped. Okay, therefore over here, the range of interval of x where the expansion is valid is x is in between of minus 1 and 1. Okay, so over here, okay, then the rest of the thing will be exercises that you can try to do. Okay, there will be a bunch of exercises here that you can do. Okay, stop recording. Okay, start recording. Well, continue from chapter 1, algebra. Okay, the next one that we're referring is modulus inequality. Okay, a modulus equation, inequality, and modulus inequality. So the strategy that we have, okay, this is an algebra technique. Okay, we can actually do square both side, analytic method, or by graph. Okay, so let's say I want to solve these questions. Okay, 3x plus 4 equals to modulus 3x plus 4 equals to modulus x plus 5. Okay, if we square both side method, so it's labeled here, you can see that we actually square both side for the modulus. Okay, so we have a 3x plus 4 square and x plus 5 square. So open up a bracket, we have a 8x square minus plus 14x minus 9 equals 0. Factorize it, I have a 1 over 2 and negative 9 over 4. Okay, so these will be the two answers that are actually proposed. If you do analytic method, okay, we actually can split into cases, analytic. Okay, split into cases. Okay, then we will have a possible of positive of 3x plus 4 equals to positive of x plus 5. Okay, positive of 3x plus 4 equals to negative of x plus 5, or negative of 3x plus 4 equals to positive of x plus 5, and the negative of 3x plus 4, okay, equals to negative of x plus 5. So you will see that these two, they are the same. Okay, these two, they are the same. So in the end, it's just two cases. Okay, so therefore we have a two cases here and here. So solve it, we have a 1 over 2 and negative 9 over 4. So this will, the next part that you need to do is do the checking. please understand that you always need to do checking in order to make sure that whether your answer is correct or not. Sometimes the answer that you got, uh, you it's not the correct answer, because due to algebra you get an extra answers. Therefore, you are required to do checking in order to make sure that your answer is correct. So what if I want to look at from the perspective of graph? Therefore, you will need to know how to draw the modulus 3x plus 4 and the modulus of x plus 5 graph. So I have a let, okay, y1 equals to modulus of 3x plus 4, okay, then y2 equals to modulus of x plus 5, okay, then I can actually draw the graph. Okay, 3x plus 4, so I will have like this. Okay, this will be a 4, this will be a negative 4 over 3. Okay, x plus 5, so I will have the shape that actually look like this. Okay, so the shape over here, so this is a uh, minus 5 and this is a 5. Okay, and this is your x-axis, this is your y-axis. Okay, so over here this will be your modulus of x plus 5 graph. Okay, this will be your modulus of 3x plus 4 graph. Okay, you will see that the x plus 5, the gradient is 1, the 3x plus 4, the gradient is 3. Therefore, the gradient 1 is flatter, gradient 3 is actually steeper. So, and from here you see that there are two intersection points. Okay, the answer is 1 over 2 and negative 9 over 4. Okay, which is consistent with the answer that we got earlier. Okay, then okay, the next example, we want to look at modulus of x plus 5 plus modulus x plus 3 plus modulus x plus 5 equals to 10. Okay, so this example, square, you have to understand that squares both sides fail. Square both sides fail. So you can see the working here, they don't even do the square both side method. Okay, what they're actually doing is the analytic method. Okay, so they will be considering of the cases positive of x plus 3 plus x plus 5 equals to 10. Okay, positive of x plus 3 minus x plus 5 equals to 10. Okay, negative of x plus 3, okay, plus x plus 5 equals to 10, and the negative of x plus 3 minus of x plus 5 equals to 10. Okay, because we have the two modulus, therefore we have 4 cases. Okay, then from here you will see that this one gives us the answer. This one gives us the answer 1. Okay, okay, this one gives us no answer, no solution. Okay, this one gives us no solution, and this one gives us the answer minus 9. Is it correct? Let me see. 1, 2, this one 10 plus, oh sorry, this is 10 minus 10 minus 8 to this is a 1. Yeah, correct. So what if the students want to do it by drawing graph? Okay, so by drawing the x modulus x plus 3 plus modulus x plus 5 graph is actually very difficult. So what you can do is you can actually draw x plus 3 equals to 10 minus modulus x plus 5. That means over here you will need to know how to actually do graph transformation for this graph. Okay, so over here, so this one, let's say I draw it as a blue, this one I draw it as a red. Okay, I draw the axis, let you see the shape. So blue color. Okay, I have a 3. Okay, 3. Then 10 minus x equals to 0, you have a 5. So the red color part. Red color part. So I have of minus 5, 5. Okay, so this is a minus 5. Okay, this one is this is a 10. This is a 5, 0. This is a 5. Okay, then you will see that you have two intersection points. The first intersection point is for the 1. The second intersection point is for the negative 9. Okay, so during exam you might need to apply your graphing technique in order to help you identify the answers. Okay, so the extension for these two questions, we can actually extend it into inequality. Okay, so inequality, let's go back to this one. Let's say I have inequality questions. So I have a modulus of 3x plus 4, okay, greater than x plus 5. With the help of the graph, you will see that I need the red part that bigger than the blue, higher than the blue. So from the graph here, okay, you can actually see that the answer that red is higher than the blue. The sections that the red is higher than the blue is x is lesser than negative 9 over 4 and x is greater than 1 over 2. That's the answer. You can actually see it from the graph over here. So what if I don't have the graph? Okay, what if I don't have the graph? Then I use test point method. Okay, test point method. Not enough space, so I write here test point method. So I draw the number line. Okay, I label negative 9 over 4 and 1 over 2, which is I already found it from the solving the equations here. Okay, then I test, okay, with the with points. Let's say more than 1 over 2, let's say I choose 10. In between negative 9 over 4, 1 over 2, let's say I choose 0. Lesser than negative 9 over 4, okay, let's say I choose negative 10. So I want to see whether the number that I substitute in is satisfied the equations or not. Okay, satisfy this equation or not. So this inequality or not. So 10 and I put it inside. So 30 plus 4, 34. This one, 15. Is 34 greater than the 15? Yes. So I give it a tick. 0, I put it here. 4, 5. Okay, is 4 greater than 5? No. I give it a cross. So negative 10, I put it inside here. Negative 30 plus 4, negative 26, modulus 26. Negative 10 plus 5, 5. So negative 5, so modulus become 5. So is 26 greater than 5? Yes, I give it a tick. So you can see this is consistent with the answer. So that means in the test point method, the step will be you solving the equation first, then only you apply the test point to see whether which one that actually fulfill the inequality. This is in the event that you don't have the graph. Okay, then you need to know how to actually use your skill to actually answer the question. Same goes for these questions. Okay, if let's say I want the equations of modulus x plus 3, okay, plus modulus of x plus 5, okay, then is lesser than 10. Okay, lesser than 10. So obviously this one is not obvious, so I move it over. So I have x plus 3 lesser than 10 minus modulus x plus 5. Okay, you will see that this is my blue part. Okay, this is my red part. So I need the portions that the red is bigger than the blue. From the graph here, you can see very clearly. So the answer will be, okay, the answer is x is in between of -9 and 1. Okay, from the graph here. So in the event that you don't have the graph, we use test point. Okay, we use test point. So how do we do the test point? So if I do the test point method, okay, I draw the number line, I label -9 and 1. Okay, so I substitute with numbers. Okay, let's say I choose 10, 0, and -10 here. Okay, I check back with my original form, the inequality. So does it fit with this inequality or not? So minus 10, I put it inside. Minus 10. Minus 10 plus 3, -7, 7. Minus 10 plus 5, 5. So 7 plus 5, 12. Is 12 lesser than 10? No. I give it a cross. 0, I put it in. 3. So 0 plus 5, 8. So 3 plus 5. Okay, is 8. 8 lesser than 10. So I give it a tick. 10. 10, I put it inside. I have 13. Okay, and I have 15. 13 plus 15, obviously greater than 10. So this one is out. Therefore, the answer is, okay, x is in between of -9 and 1. Okay, that will be your inequality. So you have exercise here that you actually can try to solve the equation and the inequality. Okay, you need to know how to actually do the work yourself. Okay, then in the end it's about graph. Okay, so from P1 you already learned about the line, parabola, cubic type A, cubic type B, reciprocal, square root, okay, sine graph, cos graph, tangent graph, arcsine, arccos, arctangent. Okay, now you deal with the modulus P3. Okay, so therefore you can see that you have been expecting to know the shape of the graph, exponential graph. Okay, we will continue to discuss about them in chapter 2 later. The log graph, okay, will be like this in chapter 2 later, and the secant, cosecant, cotangent, we will talk about them in the chapter 3. But what important is the transformation. Okay, what important is the transformation. So you already know that the shape, okay, this one is going up, this one going down, this one going to the left, this one going to the right, this one is vertical stretching or compress. Okay, this one is a horizontal stretching or compress. Okay, this one is up down reflection. Okay, this one is left right reflection. Okay, this one is reflection by the line y equals to x. Okay, this one is a reciprocal transformation, and this one is a folding. Okay, folding. So let's say for the quadratic graph, so you'll be folding become like this. Okay, folding. So this one, 12 and 13 will be something extra that you need to know. Okay, 12 will be will follow this instruction. Okay, delete the left hand side of y-axis. Okay, copy and reflect right hand side to left hand side, and this one we delete the right hand side of y-axis. Okay, and copy and reflect left hand side to right hand side. Okay, let's say you have the graph of, let's say this is a y equals to x squared minus 2x. Okay, so this is 0, this is a 2. Okay, So this is your fx, let's say fx, f of x. Then for your information, your f of modulus x graph will be look like this. The -2 and 2, f of modulus x graph. Okay, and your f of negative modulus x graph will be look like this. So this one will be look sharp. Okay, pointy. So therefore, over here there will be graph transformation that you need to learn in order to deal with the modulus type of questions later. Okay, that's all for chapter 1. Okay, stop recording.